Hey guys, hello and welcome. And today we'll talk some of the most important topics that I have ever discussed in my life. So G plus 10 building, there is a ground floor plus 10 floor more building, residential building project. So we are going to design the electrical drawing and we'll do the electrical drafting. So this is going to be very much interesting. So let's start it. Like if you are going to create if you are an electrical engineer, so company will come and ask you like, I want to build a 10 floor building, right? Tell me what should I do, how should I do for electrical wiring, and give me the electrical design. So then engineer comes into the picture. So how you will do? So few things we need to know for a building. First is we need to calculate the load, the total connected load, TLC. So first we have to do the load calculations. So what are the common loads plus what is the flat loads and what is the demand factor. Number two is the transformer size. So if this building is going to use a transformer, a separate transformer, in general cases they don't use. So but if they are using, so what is the standard size they should use, and what are the ratings should be of a transformer, what size we should use, and what are the standard size we have in the market. Fine. Number three is circuit breakers. Yes, we need to protect our devices in the electrical design. We first consider our protections in a building. We will first think about the protection. For protections we have a device, the device called circuit breakers, and also for transformers we will use, and circuit breakers for main panel. Yes, circuit breaker one for transformer that we are going to use, and if we are not using, so also we have to use in main panel, right? So circuit breakers for main panels, there is different kind of circuit breakers: MCCB, MCB, RCB, RCCB, LRCB, and different sizes are there, like 2 amps, 4 amps, 63, 40, 10 amps. There is different, right? And also then after we have to prepare the AutoCAD drawing. Yes, we have to prepare the drawing and SLD. So SLD as well as the electrical drawings, like standard size of the wall, switch boxes, then powerhouse drawing, what are the device we're gonna use, like how many MCBs is required, what are the controls, where we'll do the control panel, right? The powerhouse panel, main panels, then sub main panels, from sub main panels to our distribution board, and DB, from DB to main DB to it's go like that, right? Let's start where so consider this is, for example, this is a 10th floor building. So this is a C2 C1, this is a ground floor, and this is a first floor. C1 C2, first floor, second floor, third floor, till 10th floor. So how many floor is there total? 1 2 3 4 5 1 2 3 3 plus 10, 13 floor total is gonna be. Anyway, so what we'll do, we'll divide all of them in one panel. Like every 4 floor we will separate with the 4 panel, one single panel, right? For example, for this floor, from 10 to 8 floor, we'll create a single panel for them, and we'll use all the MCBs and all for this floor only. We'll control all these 3 floor from this panel number 4, right? Okay, same way we will control the 7 6 5 as well as the 2 3 4 in separate, as well as C1 C2 and G, and first floor we will control in panel 1. Okay, this is how we are divided, because we can't put everything in one box. It will be very much messy, and like it will cost more. You have to like think about the wire also, how much it will take to wire, to take all this from a single box to every pole, every floor, right? So it is not a efficient way to do that. Anyway, we will divide it into 4 panel 1 to panel 4. Fine. Now here is same way, we just I just show you in the pyramid sections. So from panel 1 is for first floor load as well as a common load. So what are the C1 and C2 as a common load we classify. And let's divide the G 10th floor building into 4 main parts. Yes, we divided it. First is the common load plus first floor load will be in a one panel, and this is for second panel, this is for third panel, and this is for fourth panel. Okay, for every 3 floor. Okay, that's looking quite nice. Okay, now this is the common load. Let's calculate the common load. So how to calculate the common load? For example, in a common load there will be a lift, there will be some submersible or borewell pump or other extra load like street light, or many other things can be in the list, right? So let's count first. So first is 3 number HP of lift. For example, there is 3 lift in a 10th floor building. So 3 lift into 10 horsepower in one into that like factor, right? HP into convert into kilowatts, 0.764 kilowatt. So it's converted, it is fine. Now it is 238 kilowatts. Number 2 is 2 numbers of 5 horsepower 5 HP borewell pump. 4 piece, like 2 numbers of borewell pump to pump the water from ground to the terrace for water supply. 4 number of HP water pump, yeah, for borewell pump to collect the water, and water pump is to send the water in the top, water pump, and in the light for parking areas or for street light in the ground and all. So there is like 20 lights, and each light is 100 watts, so 200 kilowatts for example. And like, yeah, so every we convert it into 5 HP into watt, right? HP, from 1 HP equals to just 746, 0.766 watt. That is why you multiply. This is the common factor. Fine. Now flat internal load. In every flat there will be, for example, each floor there is one floor, first floor. So each floor there is a 4 2 BHK. For example, 1 2 3 and 4. There is a 4 piece 2 BHK, and 3 piece 3 BHK, 3 BHK, and 3 piece 4 BHK. Okay, and also 3 piece 4 BHK. BHK means bathroom, hall and kitchen. Sorry, it's not bathroom, bedroom, hall and kitchen. Okay, 3 bedroom, hall and kitchen, 4 bedroom, hall and kitchen. Anyway, so each floor, for example, one 2 BHK room, 2 BHK means 2 bedroom. So if there is a 2 bedroom, this is 1 bedroom, this is 2 bedroom, and one is a hall room, and another is a kitchen room. So kitchen, hall, 1 bedroom, bedroom 2. Fine. Now what is the requirement? 4 number of 5 kilowatts meter, energy meter. See, as far as the government recommendation is, in 2 BHK we can use 5 kilowatts of energy meter. We can't use a more than that. That is the maximum limit. So a 5 kilowatt of energy meter, and why you multiply with the 10? Because there is a 10th floor. Every floor, 10th floor, flats internal load we are calculating. 10th floor, 4 numbers of 2 BHK, and every 2 BHK we can use 5 kilowatts of energy meter. So that is 200 kilowatts for 2 BHK. And every 3 floor we can use 7.5 kilowatts of energy meter, and 10 number floor again, and in every 4 BHK we can use 10 kilowatts load maximum. So in total we have 725 kilowatts of load. This is flat internal load. And what was our common load? Common load is 65, and is our internal flat load, consumer load. Yeah, it's mentioned here. Bedroom, hall, kitchen, and EM is energy meter according to the government standards. Now let's calculate that. So common load plus our internal load is 795 kilowatts. For example, for sake of argument, let's count it like 800. It may go increase, right? So 800 kilowatts. Okay. Now peak demand. What is peak demand? Like it can go increase. So peak demand factor. There is a peak demand factor is 0.7. Okay. Demand factor. So peak demand into total load calculation is equals to, so maximum, like not everyone will turn on everything, right? It is not like in every, like at night people will only start turn on the lights and fans and all, not in every day, not in day, right? So that is what we calculate the peak demand. So our peak demand is 0.7, and into our total load, so is equals to, so total load we require every time is 550, for example 600 kilowatts. Okay, so in Indian standards, why we are multiply with 0.7 is because in Indian standards, like we have a 60-70% is the peak demand in every residential, 70% for residential, 60 to 70 because it's a residential flat, for 80% for commercial, and industry is 90% peak demand is there. They, now we have to count, we have to we calculate transformer like load, right? Load is our 790 800 kilowatts is our total load calculation, we can did it, and total peak demand we can kilowatts. Now use 800, we can three phase, right? We have to see how many type of circuit breaker we have. This is our list is given, as you can see. This is the transformer size, 2500 kVA up to is three phase is available. For three phase is 15 to 250, and for single phase is 10 to 900. Now circuit breaker, MCCB, ACB. ACB is air circuit breaker, and MCB is like 0.5 amps to 63 is the highest circuit breakers you can use. But if you want to use more higher rating, like in industry, we use 630, like from 8 amps to MCCB, miniature circuit module current circuit breaker. That is what the MCCB, module current circuit breaker, but MCB is a miniature circuit breaker. Anyway, now what we have to do is ACB is mostly we use in industry, MCCB is for commercial, and MCB for normal household. Fine, that's good. SLD, you see, this is a 11 kV transformer is there in for giving a load of 440 voltage, 440 volt, 11 kV supply. We use a transformer from 11 kV to 440. That is like government is doing it. Now they give us 4 RYB and N, red, blue, red, yellow and black, and one neutral, three phase. And here we're gonna use a 1250 amps 3 pole ACB air circuit breaker. Why you are using 1250 ACB 1250? This is, so that is also like we have to select which circuit breaker is required for us. Here is the panel. Every panel is 500 and 250 amps 3 pole MCCB we're gonna use, and every MCCB have an energy meter. For panel 1 we're gonna do them. We will explain in the next video. SLD diagram, we calculate the loads and why you are using